All right, welcome back to the deep dive. Today we're getting into something pretty cool, pretty visual. We're talking about motion in programming, specifically how to make shapes move on a screen.
Exactly. And we're focusing on how to bring movement to life using step events. If you've just learned about step events, this is going to be perfect for you because we're going to unpack how they make things actually move.
Awesome. So for this deep dive, we're going to be working with some material that shows us, how to get things moving using code. It focuses on some basic concepts like using step events to move circles around on a canvas. So where should we start?
Well, I think our mission for this deep dive is to really make sure we understand how to create different types of motion, not just straight lines, but up, down, and diagonally, using some relatively simple programming techniques.
Yeah, absolutely. And the cool thing is, these are like the building blocks for all kinds of animations you might want to create later on.
Exactly.
All right, so let's jump right into it. Let's talk about straight horizontal motion first. So imagine you've got a circle on your screen. What's the most basic thing you'd need to change to make it slide across, say, from left to right?
Well, you'd need to change its horizontal position, right?
Right.
Which in programming, we often refer to as the x-coordinate.
Uh-huh.
Now, in these examples we're looking at, that property is actually called center x.
Okay, center X, got it.
So the first code snippet we have here shows a navy circle, and inside what's called the onStep function, which, as we know, runs repeatedly. You see this line. c.centerx plus equals 5.
Okay, so every time that onStep function runs, it's adding 5 to the circle's horizontal center, so it shifts a little bit to the right.
Yeah, exactly. And when that happens repeatedly, over and over, it creates that illusion of smooth movement across the screen.
Got it. Now, what if you wanted that circle, or maybe a different one, to go in the other direction, to the left?
Oh, in that case, you would just decrease the center x.
Oh.
The second example shows exactly that, where there's a gold circle, C2, and its horizontal position is being updated with c2.centerx equals 5.
So instead of adding 5, we subtract 5, and that makes it move to the left.
Yeah, straightforward. Right.
Makes sense to me.
Yeah.
So moving right, moving left. Now, the material introduces another idea that I think is pretty neat. It's this idea of using something called dx.
Right. And that little triangle symbol in math, delta?
Yeah.
That means change. And that's exactly what dx represents here. It's the change in center x.
So it's not the actual position, it's how much the position is changing.
Exactly. So instead of directly adding or subtracting a number in the onStep function, what we do is define a dx property for each of our circles first.
Okay.
So for the navy circle moving to the right, we have c1.dx equals 5. And for the gold circle moving left, it's c2.dx equals -5.
And that negative sign is what tells the program it should be moving to the left.
Exactly, yeah. So then inside the onStep function, we have c1.centerx plus equals c1.dx and c2.centerx plus equals c2.dx.
Yeah. Okay, so in both cases, you're adding dx to the center x, but the value of dx determines the direction. If it's positive, it moves right, and if it's negative, it moves left.
Yeah, exactly. That's a very important takeaway. You always add dx to update the position. The sign of dx determines the direction.
Okay. But why do we do it that way? I mean, it seems like an extra step. Why not just add or subtract directly in onStep?
I get what you mean. It might seem a little bit more complex at first, but separating the change in position from the actual position update itself has a lot of advantages. It makes your code more readable and organized, especially as you start to introduce more complex motions and behaviors.
So it's kind of like setting a speed and direction in one place, and then just applying that change consistently in the step event.
Yeah, that's a great way to think about it. And, the material has a quick checkpoint here. It says, in the previous example, we use c1.dx. When used this way, which of the following is true? dx is a custom property of c1.
What do you think?
Well, we created c1.dx ourselves, right? We assigned it a value of 5. It's not something that all shapes automatically have, like center x.
Right, it's not built in.
Yeah.
So yeah, I'd say dx in this case is a custom property that we've added to c1.
Okay, so by making dx a custom property, what advantages does that give us over, say, just adding a fixed number directly in the onStep function, especially when things get more complicated?
Well, think about it. If you wanted to make the circle speed up or slow down over time, having dx as a separate property makes that super easy. You just change the value of dx and you're good to go.
But if you were directly adding or subtracting a number in the onStep function, you'd have to find that specific line of code and change it every time you wanted to adjust the speed.
Exactly. It's a lot less flexible and a lot more work.
Makes sense. Okay, so we've covered horizontal movement, left and right. Now, what about vertical movement? What about going up and down?
Well, vertical motion is Very similar to horizontal motion, actually,
Uh-huh.
except instead of changing center X, we change center Y, which controls the vertical position of our shape. Okay, so same idea, just on a different axis.
Exactly. And just like we use dx for the change in horizontal position, we use dd for the change in vertical position, delta y.
Okay, so we're thinking about top and bottom boundaries instead of left and right.
Precisely. And the code looks very similar. We define a duty properties for our circles, so for a navy circle moving down, we might have c1.dd equals 5.
And for gold circle moving up, we use a negative value, like c2.d equals 5.
You got it. And then in the onStep function, we update the vertical positions with c1.centerY plus equals c1.dd and c2.centerY plus c2.dday.
So it's the same pattern as before. We're always adding d to center y, and the sign of dd determines whether it moves up or down.
Yeah, exactly. It's a consistent approach.
And that consistency is really helpful, especially when you're first learning this stuff. Now, there's another checkpoint here. It asks, what does CDID mean? And the options are the amount of change in the vertical position of C, the amount of change in the horizontal position of C, and the horizontal position of C.
Well, it's definitely the amount of change in the vertical position of C.
Yeah, the Y in a jummy makes it clear that we're talking about vertical movement, and delta always means change.
Right. So CDD tells us how much the vertical position of circle C changes with each step.
Okay, I think we've got a good handle on up and down movement now. So let's get to the really fun part. What if we want to make a shape move diagonally? So not just left, right, up, down, but a combination of those.
Now, this is where we bring it all together. Diagonal movement is all about changing both the horizontal and vertical positions at the same time within that same onStep function.
So we're telling the shape to move a certain amount horizontally and a certain amount vertically with every single step.
Precisely. And to do that, we need to define both a dx and a duty property for our circle.
Okay, so in the example, they have one circle with c1.dx equals 10 and c1.d equals 5, and another with c2.dx equals mogadent 5, and another with the c2.dx equals aren't the same. What does that tell us?
That's the key to creating diagonal movement. It means that the circle will move at an angle because with each step, it's moving more horizontally than vertically. If you flip those values, it would move more vertically than horizontally.
I see. So by adjusting those dx and dy values, you can control the angle of the diagonal movement.
Absolutely. It's like deciding how many steps you take to the side for every few steps you take forward or backward.
Perfect analogy.
Okay.
Now, one last checkpoint here. It asks, in the previous example, we set c1.dx to 10 and c1.da to 5. What would happen if we reverse these and set c1.dx to 5 and c1.d to 10?
Well, if we swap those values, the navy circle would still move diagonally, but its path would be much steeper. It would be moving more vertically than horizontally.
So by playing around with those dx and d values, we can create all kinds of diagonal movement. It really shows how these simple horizontal and vertical changes can be combined in powerful ways.
Absolutely. So to summarize, we've seen how the onStep function is like the engine for animation. It lets you create the illusion of movement by repeatedly changing a shape's center X and center Y.
Right. And using dx and die to represent those changes makes your code cleaner, more flexible, and it opens up a world of possibilities for creating different types of motion.
Exactly.
So what if you didn't just set dx and die to fixed values, but actually change them over time? What kind of effects could you create then?
Ooh, now that's an interesting thought. What if you wanted to simulate a bouncing ball, for instance?
Yeah. As the ball bounces, it loses energy, so it slows down a bit with each bounce. You could achieve that by adjusting the die value, right?
Precisely. You could start with a high die for the initial bounce and then decrease it slightly with each subsequent bounce. That would create a very realistic bouncing effect.
That's so cool. It really shows how understanding these basic principles of motion can empower you to create all sorts of amazing animations.
Absolutely. The possibilities are endless. It's all about experimenting with these concepts of dx and die within the onStep function. See where your imagination takes you.
Great advice. That's all the time we have for today's deep dive. Thanks for joining us.
It was a pleasure being here. Until next time.